Hello, everyone. My name is Shivang. I work at Block, formerly known as Square. I'm an Android engineer on the MDX team, which stands for Mobile Developer Experience. On this team, I work specifically on what we call the inner loop, which focuses on local development experience. This includes build speed, IDE performance, and just building custom tooling to increase engineering velocity. Today, I want to share with you a system we developed to leverage developer machines to turn idle time into real developer productivity. In particular, how we used it to improve Square Android's configuration cache hit rate by 18% and decrease the average build duration by 14%. I'll start off by talking about the problem that we're trying to solve, which is improving engineering velocity for local development, specifically build speed. I will then briefly talk about the current state of our build, specifically the configuration phase, and the strategy we came up with to increase the cache hit rate. Next, I'll talk about a unique system we built to leverage developer machines to execute jobs in the background. Then I'll talk about how we use this system as a foundation for pre-warming our Gradle builds. Finally, I'll tell you about how we scaled this system so that it can be leveraged across different teams and platforms to further boost developer productivity. The Square Android project is a mono repo. It has almost 7,000 Gradle modules and close to 200 active contributors. Given the scale of this project, and the velocity at which the codebase grows, as seen in this chart showing the monthly module count for the last few years, build speed is always a high priority. The Gradle build lifecycle has three phases: initialization, configuration, and execution. We have leveraged Gradle's incremental build, local build cache, and configuration cache to optimize the build performance as much as possible. Despite these efforts, build speed remains a challenge for an ever-growing codebase. So we're always on the lookout for opportunities to address this issue. Given that configuration phase is a significant part of the build, we decided to do some investigation around the current state of our configuration cache. What is the configuration cache? The configuration cache improves build performance by caching the result of the configuration phase of a Gradle build and reusing it for subsequent builds. In order to calculate the configuration cache hit rate, we can use DevVelocity's Gradle configuration cache API, which takes a build ID parameter to get the outcome of individual builds. The outcome tells you if there was a cache hit, miss, or a failure. By aggregating the outcomes of all builds, we can find the overall configuration cache hit rate to be around 65%. Given the size of our project and the number of developers actively contributing to the codebase, it is not surprising that there's a high frequency of configuration cache invalidation and the hit rate being so low. The next thing we did was try to figure out the most common reason for why a configuration cache miss occurs. We did this using the DevVelocity Gradle configuration cache API. This provided us with the insight that about 60% of our builds that had a cache miss was due to no cache configuration being available. This validated our previous idea that due to the scale of the codebase and the frequency of code changes, configuration cache was just not available for a lot of the builds. We then tried to determine how much build speed improvement we could expect to see if we increase the configuration cache hit rate by an X amount. By measuring the hit rate, the average duration for a build with a cache miss, the average duration for a build with a cache hit, and the aggregated average duration for all builds and the total build count, we were able to calculate that for every 1% increase in the configuration cache hit rate, we can expect about a 1% decrease in the overall average build duration. During a conversation with a teammate, we were brainstorming on how to increase the cache hit rate. The cache miss reason of no cache configuration being available sparked an interesting idea. What if it was available? What if we can do something to make the cache available by the time a developer executes a build? I wasn't sure if this was a clever idea or an incredibly naive one, given how many number of inputs that can affect the configuration cache. We pitched it to our team, to the Android Study Group Slack community, and also to an ex-colleague and Gradle's own solutions engineer, Inaki. There was a lot of optimism around it, so given the potential build speed impact, we decided to give this a shot. Some impact scoping and conversations like this was the inception of what this talk is about. Imagine this scenario. As part of your daily workflow, you update your local Git branch with the latest code changes from remote. You step away from your IDE and decide to check your emails, Slack messages, join a meeting, or take a coffee break. 2 minutes, 5 minutes, 10 minutes later, at some point in the future, you come back to your IDE and execute a Gradle build. In your build logs, as expected, you see this message. calculating task graph as configuration cannot be reused. That indicates that configuration cache is invalidated and your build now has to go through the configuration phase. Now imagine the same scenario. You update your branch with the latest code, you step away from your IDE for some time, and at some point in the future, you come back and execute a Gradle build. In your build logs, you see a surprising message that says, reusing configuration cache. How did this happen? Well, while you were away, your computer kept working on your behalf. It automatically started a Gradle build in the background. So by the time you came back and executed your own build, this background build had already gone through the configuration phase and created a cache entry for you. Your build is now able to reuse the cache and skip the configuration phase entirely, resulting in an overall faster build. These background builds are regular Gradle builds. However, they're executed automatically on the developer machine in the background, away from the peripherals of the developer. The developer may not even be aware that this build is happening. These background builds are executed with Gradle's dry run flag. This flag allows us to run just the configuration phase of a build while skipping the execution phase. This is crucial for creating a cache entry quickly without the resource overhead of a full build. As we talk about this strategy, you'll hear me say the term background build a lot. Before we dive deeper into pre-warming the configuration cache, I want to tell you about the foundation on which these background builds are executed. I would like to introduce to you the MDX Daemon. The MDX Daemon is a lightweight process that continuously runs on developer machines. It consumes signals emitted from developer actions and executes long-running asynchronous jobs in the background to increase developer productivity. The daemon is auto-installed onto developer machines by our platform engineering team using macOS Launch Agent to persist the daemon so that it is always running. Now let's understand what an MDX daemon job is. It is a repetitive, predefined task to be executed in the background on the developer's machine in a passive manner. A job consists of two parts. One, an executable script. This defines what to execute. It contains the actual commands required to accomplish a task. Second is a job configuration. This defines how to execute the job. Two key pieces of information the configuration contains is the name of the script that should be executed and the URL of the Git repo cloned on the developer machine that this script should be executed for. The job configuration is defined on a remote feature flag platform. Just like the MDX daemon, the scripts for each job are also auto-installed onto developer machines, but independently from the daemon itself. This way, the daemon is completely decoupled from the jobs it executes, allowing us to iterate and ship new jobs on the fly. This diagram represents the developer machine demonstrating how the daemon actually works to execute a job. The entry point to the MDX daemon is a REST interface that exposes two endpoints and runs on localhost. The two endpoints are for job execution and cancellation and take a job ID parameter. When the daemon receives an execute request with a job ID, it will first reach out to our remote feature flag platform to fetch the job configuration that we talked about in the previous slide. The daemon will then use this configuration to perform some steps before the job is ready to be executed. It will perform some validation to determine if this job should even be executed for a particular user in the first place. It will then use the job script name to find the script file located on the machine, and then it will use the Git repository URL to resolve the working directory of the Git project from where the script should be executed from. We then use Java's process builder to execute the script and store the process ID along with the job ID in a log file on the machine while the job is in flight. When the daemon receives a cancellation request for a specific job ID, we can then use this process ID to terminate the job. Now that we understand how the MDX daemon works and executes a script based on a job ID, let's talk about how the system can be leveraged for pre-warming Gradle builds to maximize cache hits. As you can see here, the Square Android project is now the client, which makes a request to execute the pre-warm configuration cache job. The daemon fetches the job configuration and locates the script it needs to execute. This script contains a Gradle command to execute a build with the dry run flag. The daemon dynamically resolves the directory where the Square Android Git repo is cloned on the machine, and then the daemon then executes this script from within the Square Android directory to run a Gradle build in the background. The question now is, how do we know when to start this background build? To effectively implement the pre-warm configuration cache strategy, we identified certain user events that provide a signal of configuration cache being invalidated. These events can be developers updating their local Git branch with the latest code changes from remote, or by modifying build scripts, generally followed by an IDE sync. We can then start background builds in response to these events, where we're essentially trying to take advantage of the idle time between cache invalidation and developers executing a build to passively create a cache entry. To start a background build in response to updating your local Git branch with latest code changes, we can use certain Git hooks such as post checkout, post merge, and post rebase. In this case, executing a simple curl command to the daemon's execute endpoint and passing in the job ID. To start a background build in response to a build script update, which is usually followed by an IDE sync, we have developed a custom IDE plugin to hook into the IDE's sync events. When the sync complete event is invoked, we know that the sync has successfully finished, and then call the MDX daemon to start a background build. This plugin is open source, so you can check out how we hook into various IDE events to interact with the MDX daemon. Now, it is very possible that after one of these events, while a background build is in flight, a developer can execute their own Gradle build from the command line or the IDE. This will result in multiple Gradle builds running concurrently. This could be very problematic as both builds will compete for CPU and resources, resulting in both being significantly slower. This would mean a regression in build performance from a developer perspective. So if a developer initiates a build while a background build is still running, the background build should be canceled. Developer builds should always take priority over background builds to ensure that there's no regression in developer experience. When a developer executes a build from the command line, Gradle wrapper script gets invoked. We can again execute a curl command from within the Gradle wrapper script to make a request to the daemon's cancel endpoint to stop the background build. When a background build is started from the IDE, we can once again leverage the IDE plugin to hook into the IDE build or sync on start event. Here we can tell the daemon to once again stop the background build and allow the developer build to execute as normal. So far, we've learned how the MDX daemon executes a job and how the daemon can be leveraged for pre-warming or Gradle builds. There's still one problem to solve. What Gradle task does the MDX daemon actually need to execute in the background? The Square Android repository is structured as a mono repo, encompassing multiple apps. This means that developers across many various teams may be working on entirely different subsets of the code base as part of their daily workflow. Some developers may build entire app verticals, some may only build feature apps, and others may switch between the two. This means that the builds that are most commonly executed vary significantly by developer. It also means that a developer can change the build target at any time as part of their implementation, as their implementation focus changes. So how do we know which Gradle task to execute in the background so a developer can benefit from a pre-computed configuration cache entry? In order to provide the most benefit for our developers, we customize the background build based on each individual developer's build history. By tracking their recent build patterns, we can try to predict which Gradle tasks they're most likely to execute in the future. On each developer build, within our build logic, we track the requested Gradle task and calculate the most popular task in a JSON file that lives on the developer machine. When the MDX daemon is triggered to execute the pre-warm job, the script will then read this JSON file and fetch the top task to execute in the background. In order to most accurately predict the future build, we experimented with various prediction algorithms, as well as the number of builds that we track. We found that we were able to get the most accurate prediction by tracking the 5 most recent builds and simply selecting the most popular one. To validate the effectiveness of background builds executed by the MDX daemon, we did some investigation. Here we have a build scan from Develocity for a build that was executed by a developer and got a configuration cache hit. The build scan provides a link, View Origin Build Scan, to the build that originally created the cache entry that the developer build was able to reuse. When we click into the origin build, we see a build that is tagged with the MDX daemon scan tag. This tells us that this build was executed by the MDX daemon and that the developer build was able to skip the configuration phase of their build because the background build had created a cache entry at some point in the past. Without the daemon and without pre-warming the configuration cache, the developer would have to go through the entire configuration phase, resulting in a slower build. As seen in our metrics, the configuration cache hit rate increased from around mid-60s to almost 80%, an overall 18% improvement. As the hit rate trends up within the same time frame, we can also see the average build duration trend down with an overall 14% decrease. This is a result of the configuration phase being skipped for a lot of new builds due to a cache hit, resulting in overall faster builds. Considering Square Android has monthly build count in tens of thousands, this is a significant win in terms of number of engineering hours saved. Here are some of the key factors that we iterated on that contributed to the success of the strategy. The first one was optimizing the prediction algorithm to determine what builds to pre-warm. This was a major contributor to being able to scale the solution to a team of 200 engineers. The second was to make sure that the background build resembled the developer builds as closely as possible by tracking builds more granularly. We did this by capturing not only the requested tasks, but also any environment variables, Gradle properties, and other flags that the configuration cache is sensitive to. The third was upgrading to Gradle 8.11. This reduced the configuration cache store and load times, causing the overall configuration time to go down. This allowed the background build to finish successfully, more consistently, and at a higher rate, and create a cache entry before being canceled by a developer build. The last is upgrading to Gradle 8.12. This introduced a new property called configuration cache entries per key, which allows us to store multiple cache entries per cache key, which helped increase the hit rate when switching Git branches, further enhanced by pre-warned builds. With our investigation of the build scans and observing the trend in the hit rate and our build speed metrics, we can truly see the pre-warm configuration cache strategy working in the real world. Now that we saw how the MDX Daemon helps pre-warming Gradle builds, how can we scale it for other tasks? When building the daemon, we designed it in a way that made it platform and build system agnostic. Any command that you can write in a script can be executed using the daemon. This allows us to not only leverage the daemon for more automation on the Android team, but also be a force multiplier for driving developer productivity across other teams and platforms. In scaling the daemon for broader use, one question that came up was, how do we make sure that a job that is meant for an Android engineer is not executed on an iOS or a backend engineer's machine? To address this, we added a new configuration parameter called roles. A user can belong to a set of roles that define their job responsibilities within the company. These roles typically are indicative of the platform that you work on, such as Android, iOS, or backend, as well as the various business units within blocks such as Square and Cash App that you belong to. For example, Square Android is a specific role for Android devs working in Square. This configuration allows the daemon to scope the execution of a job only for the users that will actually benefit from it, and skip it for the ones that don't need it at all. So far, we've only talked about a job that is executed by a user event, such as a Git hook. But some jobs are not suitable for that. Some jobs require automatic periodic execution. So we added a cron job capability. In the configuration, a cron schedule can be defined to let the daemon know to schedule a job to be executed on a fixed interval. Let's take a quick look at how some of the jobs use this capability. Here are a few of the use cases where the MDX Daemon's cron job and roles configuration is leveraged to automate various tasks across multiple teams. The Android team uses the daemon to run a custom IDE provisioner tool that automatically bootstraps the latest Android Studio and custom IDE plugins. Relying on developers to execute this themselves has always led to inconsistent, outdated tooling and preventing the MDX team from shipping new performance wins. With the daemon, this job is completely automated and executed on a weekly basis to ensure developers always have the latest tooling and removes the overhead for developers to having to manually execute it. Cash App's backend DX team, which uses Gradle, implemented a daemon job to preemptively download dependencies from a flattened dependency list file. This includes both direct and transitive dependencies. This job is triggered by Git hooks as well as on an hourly basis and has reduced their dependency download times by 75%, significantly improving their IDE sync performance. The Square iOS DX team uses the daemon to monitor developer machines' disk space and automatically deletes old artifacts past a certain threshold on a daily basis, solving a major point of disruption for iOS engineers. The team also uses the daemon to regularly monitor errors related to Xcode to get ahead of the problem rather than waiting for developers to raise the issue. As we shared the learnings from the success of background builds to boost configuration cache, the daemon started to become a significant lever within the DX teams across block. Whenever a new problem space is identified in the local development cycle, where something is too disruptive or taking too long, one of the first questions that gets asked is, can we automate this with the MDX Daemon? Across Block, the Daemon currently runs on more than 1,600 developer machines for a wide range of task automation. In my opinion, the MDX Daemon truly embodies the principles of developer productivity engineering, as it measurably impacts developer velocity without adding friction or changes to their workflow. I would like to conclude this talk by asking you, if you had the MDX Daemon available now, how would you use it to improve your team's local development experience? And that's all. Thank you.